Morning, ladies and gentlemen. You don't have to do that for me. It's just for Steve. You have to do that. I'll tell you when to applaud. Don't worry. And, I heard a lot of talk about people falling asleep. Well, through no fault of anyone but my own, nothing to do with Guinness, India Pale Ale, or Scotch, or any other alcohol, I managed 2 hours and 57 minutes sleep last night. So if anyone does want to fall asleep, I'm here to tell you that's okay by me. I'll join you in a little nap. I notice right here it says first draft. That would lead you to believe there's a second draft, right? So if I dry up in the middle of it, it's because I just cannot read this stuff. The National Energy Board of Canada is accountable to the people of Canada for pipeline safety, protection of people, and protection of the Canadian environment. In light of that accountability, we take a cautious approach to risk associated with pipelines. Nonetheless, we recognize that although pipelines are very safe, they are not infallible, and therefore operational risks have to be accounted for and controlled to continue to provide a high level of safety. I'd like to talk to you briefly about the NEB's expectations with respect to risk assessment methodologies, and present a few, actually two, case studies to illustrate where risk assessment has successfully been used to address operational challenges. First of all, very briefly, who we are. The board, the National Energy Board, is an independent quasi-judicial body. It's a court of record and it acts on official record brought to its attention. The board is also a life cycle regulator, addressing all phases of pipeline's life, from design through construction, operation, and ultimately to retirement of the facility. The board regulates pipelines that cross provincial and international boundaries. In the latter case, of course, which would be between Canada and the US, we regulate the northern part, and PHMSA regulates the southern part. And for that reason, we have a very strong relationship with PHMSA and are in frequent communication with them to identify best practices and to ensure regulatory consistency. I'm actually thinking of having Steve as sort of honorary member of the board. Jeff Weiss tells me he's thinking of having Steve an honorary member of PHMSA. Jeff's not here, eh? He's not in that thing, is he? He might be. Okay. That'd be one more damn beer I'd owe him. Okay, this slide illustrates the system the board regulates. If a pipeline is wholly within a province, then it's covered, it comes under the purview of the provincial regulators. So in British Columbia, that would be BCOG. In Alberta, it would be the Alberta Energy Regulator. The board's regulation is actually a mixture of prescriptive and performance-based elements. There is a definite movement towards introducing more performance than prescriptive, but there will always be a prescriptive element. The basic principle is that the pipeline operator remains ultimately responsible for the integrity and performance of its pipeline system. The board's expectation of companies it regulates with respect to risk control are somewhat summarized in this slide, which is an excerpt from our onshore pipeline regulations. Now, people used to PHMSA's regulations will see the word hazard. Just read it as threat. For some reason, we like to be a little, actually we have no choice but to be a little different. We are a little different up north, so we use hazard instead of threat. It has occurred to me that we could probably use both. For me, the bear is a hazard. The bear coming towards you is a threat. This has not grown legs anywhere on the planet, but I haven't given up on it yet. So for today, if you would just carefully, just read threats where you see hazards written here. So establish and implement a process for identifying the hazards. And we did actually see that on one of the Steve's presentations this morning. Establish and maintain an inventory of identified hazards. Establish and implement a process for evaluating and managing risks. And establish and implement a process for developing and implementing controls to prevent, manage, and mitigate the identified hazards and the risks. Steve Allen talked a little bit today about the overall process of risk management and risk control. At this point, F speaks to that. I heard something of a sentiment with which I agree, is that the index methods are getting towards the end of their useful life, and I'm going to talk about that a little bit as we go forward. However, I want to offer a little description of an index-based method we do use ourselves at the NEB. The NEB doesn't really do any work. It's not unlike PHMSA in that regard. But we do require certain things of operators. But this is one place where we do a little bit of risk assessment, and it's an index-based approach. We use it to prioritize our regulatory oversight and to prioritize our regulatory actions. So I'll present a brief description of it. It's as an example of a non-QRA or index-based approach to risk assessment. It works simply, of course, on the basic notion that risk is probability of failure times consequences of failure. Probability is a function of adequacy, implementation, and effectiveness of a management system. And I think also Steve Allen mentioned, someone mentioned a little bit about management system. That is the basic tool by which we expect companies to manage their pipeline integrity. And what we're trying to get at by this tool is to rank these companies in a logical fashion so that we prioritize our oversight of the companies accordingly. Oops. Clearly this slide wasn't put together by me. It's way too clever. See, it does things like that. I did insist that it didn't have the screeching tires effect when it came in, so you'll be glad to know. So consequence receptors, so far we've developed consequence receptors for 3 areas of interest in the facility life cycle. And we're interested in capturing relative consequences that can be consistently replicated across any pipeline system. I won't go over these in detail. You can read what's there. The risk, the decision model that comes out of this risk assessment is a simple risk matrix. I notice it's 9 by 9. You know, I think we could do with fewer, I beg your pardon. I think we could do with fewer. In fact, I could do with 2 by 2. I think that would work really well for me, but that's another concept that appears not to be growing any legs. For companies whose risk profile falls into the red, obviously this is a must-do activity. The compliance verification is heightened for these companies. And for yellow, it's a will-do. We'll eventually get to it, but it's a second priority. And green is companies that have a profile in the green are continuously monitored to check if their risk status changes. Now, we heard that also, that's a very important part of risk assessment, is you don't just do it once and then forget about it. You have to continually make sure that any assumption that you've made holds through the life cycle or the study cycle of the pipeline. And if the risk changes, then it changes to some other point on this matrix. So the NEB has accepted quantitative risk assessments in a few cases, where the risk model was used to benchmark mitigation actions against established risk reduction measures. And the sort of basic methodology is in a non-mandatory appendix to our code, Z662, Annex O. And this is a reliability-based design and assessment of onshore, non-SAR service natural gas transmission pipelines. So we start here and we come right down to Big Inch going across the country. As I say, it's non-mandatory. It's there for guidance. The NEB approval of the annex itself is still pending a little bit on the targets that are chosen. However, the methodology has successfully been used in a comparative study. Now, it seemed to me that Steve Manick mentioned that too in talking about the highest relative risk. So where we are comfortable right now with QRA is if it is used in a comparative situation where you take a scenario that's accepted as acceptable, and then use the QRA to determine whether the mitigation measures that you've put in are equivalent to that. So I mention it here briefly only because it is the sort of the basis of the two studies that I'm going to present to you. And I would commend, notwithstanding the apparent complexity of QRA, I would commend the use of it to you. In as much as anything, it brings a certain rigor. And is Mark Stevens, has he gone to the toilet again? I saw him fidgeting a few minutes ago. But he doesn't seem to be here, so that's good, so I can talk about him. As Mark says, when you don't use QRA, it's discussion, 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 and then the hand-waving starts, right? So at least it gives you a framework within which you can apply a certain amount of rigor. Whether you go to the full complexity of it or not depends, as was noted by Steve Allen, depends very much on what you're trying to achieve and what system you're addressing. Okay. I asked Steve how we're doing. He says you get plenty of time. Wrong answer. Case study number one. So both of the case studies, incidentally, we're going to present are deferrals, in class location deferrals, places where the operator, the class location changed, so we're talking obviously gas. The classification changed, and the operators elected to leave the pipe as it was and do other stuff. And it's the case studies describe how they got to what other stuff they did and how we evaluated that. The first example is an encroachment of a 42-inch pipeline, NPS 42, with expansion of a campsite beside it. And there's some description here of what it is. It's high pressure, 6,450 kPa, large diameter. It's over a kilometer long, and the proximity of the campground. And I counted all the little dots, and there's about 41 of them. So the NEB requirements are essentially the requirements that are given in Z662, which is incorporated as part of our regulations. So which is a little bit different from how things are done with PHMSA, who have their own regulation. There's advantages and disadvantages in both approaches, but it's worthwhile noting that in Canada, the national standard is actually incorporated into the regulations of the regulator. So the NEB requirements are either replace the pipe, lower the pressure, or produce an engineering assessment that shows that the pipe is fit for continued service. Now, the company in question, their approach was to do a 3-level analysis. First one was just a code check to see if it did in fact pass code. Obviously it didn't, because it was a class change. There's a good chance it's not going to. But it gives a fair indication of where it doesn't meet the code and what things have to be done. In this case, simply it was a stress level, a wall thickness consideration. The company then goes on to identify the hazards, the threats, and in this particular case, it was just 2. It was external corrosion and mechanical damage. And then, on the basis of a quantitative risk assessment using these 2 threats, they determine what mitigating measures they can actually apply and satisfy the regulator. This is kind of what it looks like. The different scenarios are plotted through a period of time. 10 years is chosen by this particular operator. And what I'm going to do is 2 things. I'm going to blow this up a little bit so that it's fuzzy and you can't read it, but it's bigger. And the other one is, here's a skill test in question. I want someone to point out the grammatical, typographical error in this. I'm not going to take forever, don't worry. It's good to humiliate everyone, not just a few people. So. Well, I'm thinking what it is if we read down here, up here, I'll point to it. That really should read, probability of failure of the heavy wall pipe that meets the requirements of CSA Z662 for a Class 2 location for both individual and societal risk probabilities of failure. You know, we don't get out much up there, so we spend a lot of time chasing these little things down. So let me go on to this sort of more fuzzy one and see if I can read it for you. The arrow, the arrow points to the heavy wall option, just by chance, but that's it, to the heavy wall option. So that becomes the target reliability. Whatever you do has got to at least meet that. The one above it is the lower pressure. It doesn't govern. Clearly the lower of the 2 governs, so putting in thicker pipe is really the thing you would do to comply with the code in this case, to best apply with the code in this case. The chart shows that improved signage and concrete slabs comes close to meeting the target. Now that is a kind of blue thing that's just above the lines that are given here as the targets. However, repairing one metal loss feature using improved signage and the use of above-ground alignment markers seems to provide, or we believe provides, significantly lower likelihood of failure, and therefore that was the approach that we used. This is very difficult to read, which is probably quite good because there's probably some copyright on it. So the case study number 1, the additional mitigation actions are listed here. Additional excavations for ILI reported dents. Reinspection interval reduced from what the company thought was adequate to 5 years. Depth of cover surveys, interval of 5 years. Now here is a case in point. I think the regulations are the same in B318, B314. There's no operational requirement to measure depth of cover. You have to do it at the design level, for sure, but in operation, I don't think you have to. You certainly don't have to do it in Canada. So, as I mentioned a little earlier, when you're monitoring risk, if you make an assumption, as in this case, the company did make an assumption about depth of cover, Now it's incumbent on the company to make sure that in their integrity management program, they have a depth of cover survey, because they must maintain that depth of cover that they used as the basis of their engineering assessment. And you can read the rest. Case study number 2. Case study number 2 actually predated the first one, and it involved encroachment by residential development. The dimensions there, it's a high-pressure gas pipeline, 24-inch, 1.5 kilometers long. And there's approximately 63 residences that would be within what you could consider the PIR, the potential impact radius. The options are the same as with case study 1. Either replace the pipe, reduce the pressure, or do an engineering assessment. And the engineering assessment followed basically the same lines as the one before. Establish what is acceptable in terms of the code. So increased wall thickness in this case is what is acceptable. I'm going to go over here and try not to fall down the stairs and point to it. The 2 lines up above are the as-is situation, when it's changed from a class 2 to a class 3, and reduced pressure. So reduced pressure doesn't do it. The thickness, the wall thickness increase again is the thing that would give you the necessary level of reliability, and that becomes the target. Now, increasing the signage, it's very hard to read that on there, but increasing the signage comes again close to the required reliability level. But as I started out this discussion, we were very cautious in how we apply the results of risk assessments at this stage until we've developed a more robust track record of their application. So we added concrete slabs, however, lowering I beg your pardon. Putting on slabs considerably lowered the probability of failure, and that was in fact incorporated into the solution that we accepted. And that's what's shown on here: increased signage, concrete slabs, public awareness programs, enhanced leak detections, and defined inspection intervals for inline inspection for geometry, crack, and metal loss. And again, just to reinforce the previous statement, an ongoing depth of cover survey. So this next slide is my favorite slide, and clearly the last one. So the thought I'd like to leave you with is this. Risk assessment, be it quantitative or non-quantitative, is not a substitute for common sense. It's not a substitute for good engineering. And it's not a substitute for the development of a healthy safety culture. Again, taking words from Steve's presentation. For me and for the board, the bottom line is no one must ever be harmed by a pipeline, nor the environment damaged. Thank you very much for your kind attention.
Thank you, Ian, for such a lively presentation from the Canadian point of view. We will now have our question and answer panel for everyone here on stage who presented this morning, so feel free to ask your question. Jim has a microphone in the back, or you could please step up here to the microphone up in the front. For those on the webcast, there's a question panel on your screen where you can ask questions. So these are questions for Steve Nanny, Alan, myself, and Ian, and Steve Allen from NAPSR. Okay. See, we have some questions here. Looks like this is a question for NEB. To what extent does NEB see applications of QRA going?
I guess this is on, is it? That's too bad. I'll have to mumble in that case. I think I kind of did touch on it a little bit in my presentation, is that certainly the board staff, of course, we have to get the board on side too, are sympathetic towards the methodology. And we see the big advantage being twofold. One is the rigor it brings to the process, and the other one is the use of it as a comparative study somewhat mitigates any of the concerns one might have of complexity. So we do see it as the way forward.
Good morning, gentlemen. My name is Mark Stevens. I'm with CFR Technologies. I guess I've got a couple of, I'm not sure if it's a question, maybe it's a comment or two. It revolves around some of the things I heard in the sessions earlier on. So as I understand this event, we're here to talk about a basis for improved risk models. The assumption is that they will help generate better risk assessment results, and that will better inform risk management processes and practices. And if that's the case, then I guess the key word is manage as opposed to, say, eliminate. I don't think we have the luxury of outright eliminating the risk associated with operating pipeline system, but I guess it's incumbent upon us to try and do the best we can to make that risk level reasonable or acceptable for all parties concerned. And when I heard comments along the lines of use the risk models to help identify threats so that they can be eliminated, I think the reality is perhaps it's not about eliminating them, it's holding them in check, which kind of brings forward the elephant in the room, which is if you're going to go down the road of developing more objective and quantitative and meaningful risk models and risk results, you need a basis for assessing what you've calculated. Because if you really want those results to inform in a tangible way your integrity management practices, you have to have some understanding of whether or not the risk you've calculated is too high or not. So again, just to make the point, fancier risk models and risk assessment results without some criteria or a framework within which to evaluate the numbers that you just calculated is of somewhat limited value. So I throw that out there for comment.
Mark, first of all, we agree with you. And what I mean by we agree with you is that's the reason for having the workshop. That is also the reason that we said a takeaway that PHMSA planned to have from this would be getting participation from industry, from the public, and coming up with guidance documents to use going forward. First, how we use the information we have on the threats, the data, how we put it together, and then what do we do with the risk results. So we'll agree with you. The next question we had was for me. That's why I'm standing up here, or I'd be sitting down with Ian. It says here, agreed with Steve's comments on the importance of attaining quality data for risk modeling. However, risk model could also be developed to help predicting risk in case of missing data. Using data in the literature or sharing data from industry, does PHMSA have a research approach in this direction to build a database that supports predicting risk using risk modeling? I'm not sure I'm the best person to to answer it, simply, I think we're working on some R&D on risk modeling. Am I correct, Jim Merrick? We do have an R&D program ongoing for that. As far as, it's like how I answered Mark Stevens' comments earlier. That's the reason we're having the workshop. Is PHMSA does plan as a takeaway to come up with guidance that we put out as guidance to begin with, and then going forward, we'll see what we do with it, whether it needs to be a regulation or whether it guidance is where we stay with it. We did something similar to this on casing evaluation. We did something very similar on guided wave UT. Thank you. Are there any more questions?
Hi, I'm speaking to a dead mic, that's what I'm doing.
You can come up here if you want.
There's not on button. Okay. Hi, I'm Marty Sadison, Director of Nuclear Safety and Regulatory Research at DOE's Idaho National Laboratory. My questions are around data as well. Throughout the discussions, I didn't hear the word uncertainty in the evaluation come up. When you talk about a quantitative risk assessment, hanging your head on one number doesn't seem to be the right way to go. So I was wondering if you've seen any examples in the safety analysis and risk assessments that actually has embraced or at least tried to address the uncertainty in their data. And is there any way or a possibility of using the risk assessments that are performed to identify where the holes and gaps are to help guide gathering information in certain areas?
I'd mentioned I'd visited one of our larger operators recently, and they walked me through their model, and if they had some gaps in data, or they didn't have a good warm fuzzy feeling about the data, there's some uncertainty, then they treated that data as if it were at a higher risk. I mean, they would give it a higher numerical value, so until they knew otherwise. So it's a conservative approach.
Well, if I could add just one thing, I mean, the quantitative risk approach intrinsically does deal with uncertainty because risk is uncertain, and the individual elements of it have some variability. You can take a mean value, but there's going to be some plus and minus around it. There are fairly well-established distributions you can use, but in the event, and this is what I hear from Steve here, in the event that you do not have those data, you do have to take uncertainty into account by using sensibly conservative values. But it's a really good question, Marty. It's absolutely fundamental to what we're doing. If it was all deterministic, hell, we could have liars do it.
And from a PHMSA standpoint, we've seen similar to what Steve Allen is talking about. We've seen some operators do a very good job of looking at the uncertainty of the data, of doing additional tests. We've seen some that have not been as conservative. So again, that's why we're having the workshop, and we plan to have guidance going forward, because we think there's a big gap there. And we've got to get everybody closer to using the same criteria. Any more questions?
I have one question. Ali Razan from IESS LLC. I mainly work in nuclear industry. I've done some other work for NASA. For sure. And I thought the presentation discussion this morning was very interesting. I was just wondering, since one of the objectives of this presentation was getting some feedback from other industries, I wanted just to make a comment in that regard. The issue of pipe failure, probabilistic fracture mechanics has been in our industry for a long time. There are some codes, like praise code, that I think Canadians just use it for nuclear, and I'm fully aware of it, that are used, that if you can't feed it, you know, like the inspection result you get from your X-ray, etc., it can calculate on your weld and your thickness of the pipe material and different type of degradation, which you call threads. It can actually come up with some predictive pipe failure rate and can actually look at also different test interval, inspection interval, and show you the effect of that. My question is that, have you guys looked at these other tools that is available of industry and perhaps can use them and guide you that where to focus on more detailed inspection data?
Yeah, this is Alan. Maybe I'd just say that's really why we're here, is to gather input on what other methods there are to use, and if there's something out there that we haven't tried, we're interested. We're all ears. That's precisely why we're here. But thank you for the question. We'll go to Steve next.
Actually, this is a question from someone from Pipeline Safety Trust. It's not really related to risk so much, but they want to know if NAPSR could make their meetings public, at least for virtual participation. Actually, I think our national conference, which we just had last week, there are portions of that conference and our regionals to that effect that are open to the public, but then there are also closed sessions. As far as making those meetings open for virtual participation, I'm glad to look at that.
Any comments, Ian, to add?
I wasn't paying attention, sorry. Actually, no, I think it did strike a bit of a chord, the question of whether we leverage off other industries. Clearly we do. I mean, fracture mechanics has been around a long time. As an undergraduate, I studied it, so it's been a long time ago. So it's been well understood in various industries. Where I would like to make a real quick pitch, though, is somewhat off the fracture mechanics side, is we leverage strongly from the aviation industry in development of safety culture. Steve mentioned it, I mentioned it too. If there were one thing we could instill in operating companies, one magic wand, it would be to have a healthy and active safety culture. And in the pipeline industry in Canada, we leverage off experience in the aviation industry to foment and develop that culture.
Okay, the next question we've got is, and I think this, Alan or Ken, probably can answer it, is where does PHMSA stand on and see the role of operators using canned vendor risk models and canned risk software packages going forward?
Well, I think there has been a role for vendor-provided risk modeling software. I think they're relied on quite heavily. I think, like any risk model, whether it's canned or some of the others that I've seen, more recently seem to be being developed that really look at big data and more ability to handle interactive threats. The key, we're always getting back to what you know about your system, the data quality, the conversation, whether you're talking the hazardous liquid IVP workshop, integrity verification workshop we had the other day. we always get back to talking about what you know about your system. What do you know about the operating environment? So that's a key. So I think it's more a factor of what you know rather than the approach as you will. I think there's a good point made earlier too, and I know with some of you, especially vendors that have who do provide modeling software, canned is the term was used. The point was made that you also need to have an SME look at it. I think it's always valid or important to, make a reality check, take a reality check. I think they're good guides. I think they're one important data point as you manage risk, but you also need to, consider the results and just, take a reality check and make sure they're valid, so to speak. So.
With state programs, we obviously deal with lots of smaller operators. In Indiana, we have 3 very large operators and another 87 that aren't so large. As far as using canned software, canned applications, I think the message that we would deliver to these operators is you need to make those assessments your own. You need to personalize those assessments. You need to bring into account local information, information about your system. And then when we go out and inspect and we pull up a plan, basically it starts off, it says, insert your name. That sort of suggests that it's not really being, you're not taking ownership to it.
Anything else? Okay.
Actually, there's another question that came in over the web and then we'll get to you next. But we've had this one for a little bit. And I would just ask for the web viewers if you would make sure you give your name and affiliation. We'd appreciate that very, very much. This one's actually for Ian, but I figured, Ian, you were concerning me about 2.5 hours sleep, so I might help you with reading this one.
2 hours and 57 minutes.
2 hours and 57 minutes. Yeah, so, and it's a little bit difficult to read, so I thought it might help you. But this is related to your case studies. How did the operators quantify the change of probability of failure due to the options presented, like slab, depth of cover, et cetera? That's part one. What program or software did they use? And then finally, was there a procedure to validate their analysis?
There is abundant literature to give you guidance on the effectiveness of various measures, like a slab, above ground alignment markers, increased signage. Curiously, you would think, this is lamentable comment on human nature, but you would think if you put a slab over the pipe, you'd be done, right? No, not so. The British Gas tried it. They tried a little experiment a number of years ago with the buried pipes, and they hired an agent to hire a contractor to dig a well. Of course, they weren't digging a well, there was a pipe down there. It's surprising how many times that excavator managed to get through the concrete slab. And just as a matter of practicality, what they discovered is if you take up a concrete slab and markers, then that's almost foolproof. So those kind of data are available. As for software, like I say, we do not prescribe what software a person should use. I'm sure there's one person, at least in the audience here, who would like us to prescribe it. But we don't do that. But we do make sure that we understand how the software works, what the limitations of the software are, and that it's applied appropriately. And as for validation, this term comes up very often. How do you validate your risk model? I've never come across a really good answer. So I go back to the closing remarks that I made, is that risk assessment is not a substitute for common sense, good engineering. You still have to apply the carbon-based unit. The humans still have to be involved in the process and take the ultimate responsibility.
Any more questions?
Hi, Shahani Karivasan from TransCanada. Just wanted to address the canned risk models as well as the fracture mechanics models that they talked about. On the canned risk models, if you have looked at risk models that have been developed by consultants and you develop it on one system and you try to apply that model on a different system, it has never succeeded. And that is because, like Steve said, there are system-specific aspects. Even the very threats that we look at and calculate using fatigue models or corrosion prediction models have not been able to be transferred, I believe, because we don't know everything about our systems, and that in itself is good information to have. But what I would really like to emphasize is risk models, when you are looking at system-specific, has to be subsystem or system-specific, because there are many aspects. If you look at even not only the local threats, but the global threats like, say, SAC. If you look at the fracture mechanics models that predict that one location would have SAC, and you run an ILI tool and you find cracks in a very different location. So that tells us that fracture mechanics models alone should not be used. Yes, it does give us information about our system, but information that a crack tool gives us much more location-specific information, and the historical failures gives us certain kind of, the good models need to be able to incorporate both the predictive mechanistic aspects, the historical aspects, as well as the assessment methodologies. And that gives us a much fuller, holistic picture of our threats.
Shahani, I appreciate your comment about the, clarifying about canned models. And yeah, I think, again, one of the reasons we're here is to, in light of what's been done, what are other methods and what are others doing, which I'm anxious to hear about here coming up, or what can we do? A canned model may lend itself to one system, but not another. If your system's not susceptible to cracking issues, perhaps it might be better. Maybe there are models that do address that. I'm not sure. Our focus as the regulator is to, focus on performance, the operator performance, and really we look to the operator to do and use the systems necessary to ensure performance, ensure safety. So that's the focus. We're asked quite often to comment on vendor products, and it's really, we have to be careful as a regulator in how we offer feedback on vendor products, because our overall goal really is performance and safety. And if one product achieves that, then, that's really what we're after, Any other questions? Anything more from the web, Joshua or Vinny? Yeah, one more. Okay, we have one more coming. Also, if you could get an idea of the number we have, I want to give a summary before we switch panels.
How will the PHMSA advisory bulletin and guidance for strengthening pipeline safety through rigorous program evaluation and meaningful metrics be incorporated into risk modeling, as several leading and lagging indicators are recommended?
Well, Steve, I'll start off, and then maybe we could tag team that one. We issued an advisory bulletin, and that was in the aftermath of, well, it was a recommendation related to that, again, and it's been mentioned a few times here, San Bruno. related to how operators measure their integrity management programs. And we gave guidance through that advisory bulletin on examples of how to do that. I think the thread, the connection there to what we're doing here is, what drives an adequate integrity management program, which a foundation of which includes risk management. You need to know what you have, and to the extent we develop out of this effort as we go forward, guidance for addressing issues such as interactive threats or guidance on risk models, then that will support the measuring of the program as well. So there's a connection in that way. Hopefully that addressed it. Steve, I don't know if you have something to add to that.
The only thing that I would say is that the leading and lagging indicators is if you've got a pipeline that's having leaks, failures, and things like that, and you're depending upon PHMSA through a compliance action order or something like that to make you go pressure test or ILI your pipeline or do something to correct it, then you're not getting it, if you understand what I'm saying. So that would be the first point that I would make, because PHMSA doesn't want to have to be the stopgap administrator through a CAO program. And let me say, we see that happening. I'm not saying that because when I come up and give something like this, I go back and look at the data and look at the information. So we do have operators that do that. The other point is to look at your maintenance information. In other words, when you go dig on the pipeline, what is it telling you? If you're, again, I always go back to the corrosion cracking threat, and I could add on to that is what are you seeing when you do that? Are you implementing that into your risk model? And then third is I'd say most of us in here that are operators have an inline inspection program. What are we doing there? Are we going out? If we're running a crack tool, how are we evaluating it? If we're running a wall loss tool, how are we evaluating it? And then what are we doing with close interval surveys and things like that for disbonded coatings? Other things that add to the threats. How are we incorporating all of that into a data integration process? And to use it to come up with our P&M measures and what we do going forward with a risk model. As far as PHMSA metrics and guidance, again, this is what we hope to get into a guidance document that we hope will happen or plan to push to happen after the workshop. Any other questions? Well, I put going to the boardwalk pipeline risk analysis to sort of give everybody the hint. It was probably time to go to the next one. So if we don't have any more questions, we'll go forward with that. Ken, would you like to introduce our next guest?